Hope you're doing great. Our today's question is interval list intersections, which is a pretty popular question with Facebook right now. Facebook, Apple, Uber, Amazon, Adobe. All right, so the question says that given two lists of closed intervals, each list of intervals is pairwise disjoint and in sorted order. Return the intersection of these two interval lists. So formally, the closed interval means that, for example, if you have an a comma b, that denotes a set of real numbers x with a less than equal to x less than equal to b. So it could be like 4 comma 5, or it could be 5 comma 5 as well. The intersection of two closed intervals is a set of real numbers that is either empty or can be represented as a closed interval. For example, the intersection of 1 comma 3 and 2 comma 4 is 2 comma 3. Right, so we would be given an input, so a pair of basically intervals, a list of intervals, that is A and B, and we want to find the intersections of these lists of intervals. Okay, so I hope the question is clear. Here, the key things to note are that both of these lists would be in sorted order. And the other important part is that we want to find the intersection which is like really clearly defined. That is, if we have 1 comma 3 and 2 comma 4, it is 2 comma 3. So the good thing to note here is that if you simply look at it, the intersection can just be found by finding the maximum of the start times of the two intervals in consideration at a specific point in time, and the minimum of the end times of those two intervals. So for example, in 1 comma 2, the maximum is 2, and in 3 comma 4, the minimum is 3, and hence the interval that we get out of it is 2 comma 3. But this is valid only if 2 is less than 3. Otherwise, the intersection is not valid. So that's what we will do. Because it's already in sorted order, we don't need to worry about sorting it on the start time or the end time. So yeah, that is already taken care of. So we'll just start with the solution, as a part of which we will be traversing through both of these interval arrays and finding the min and the max, as I just mentioned, and seeing if that creates a valid interval intersection. Then we would add it to the result, and if it does not, then whoever interval ends first, we will move that interval's pointer to the next one, because that has already ended. The other one is still existing, so we might still find an intersection between this one and this one, and that's why we just move the one ending earlier. Okay, so let's get started here. All right. So first of all, let's have some checks. So if A equals to null and B equals to null, yeah, or A dot length equals to 0, B dot length equals to 0. So in this case, we just return a new int array, and that's it. Okay. Well, so otherwise, I'll just take an I, which is equal to 0, and j, which is also equal to 0, which will be our pointers for both the arrays A and B. And we'll have to take an array list of interval of int arrays, which will be our result. Okay, so now we just have to use a while loop, which says while I is less than A dot length and j is less than B dot length. Okay, so we'll just get, first of all, we'll just get the min and the max. So the max has to be the maximum of the start times of both the intervals, that is a of I of 0, right? That is the start time, comma, b of j of 0. And the min has to be the minimum of a of I of 0, sorry, of 1, and b of j of 1. That is the end time. Okay, so now if this forms a valid interval, the maximum, that is the maximum of the starting times, should be less than the minimum of the ending times. So we just check if max is less than equal to min. So it could be 5,5 as well. As you can see in this example, we do have 5,5 as well in the output. So we just check for equality as well. So if the maximum is less than equal to the minimum, then we should add to the result a new integer array, and we just give it max comma min. All right. Okay. Now we have to move one of the 2 pointers irrespective of whether we got an intersection or not. So for that, we'll just check if a of I of so we have to compare the end time. So if of 1, if that's less than the b of j of 1, that means the a of I interval ends earlier. So in that case, we move I, right? Else we just move j. Okay, so we just keep doing that till this is valid. And at the end, since we have to return an integer array, I'll just create one over here. Result, let's call it result. Just a new. And so now I always know that this is going to be 2, and the size will be equal to the array list size, right? Okay, and now I can just have all of these. Let's just call it A, and I'm getting that from result, and we can just add. Oh, okay, I need a for loop here. Okay, can just use this. I should be less than the result dot size I plus plus, and here I can just say that okay, result of I equals to result dot get I. Okay, and then we return result. Sounds good. Let's see if this works. Okay, yeah. Okay, it says the dimension missing, so I could just go with 0. Alright. That worked. Okay. Alright, so that works. So the time complexity here is O of m plus n, where m and n are the respective sizes of A and B. The reason being that we would have to in any ways travel the entire length of both the arrays. So that gives us the combined time complexity. And the space complexity, I suppose, would also be equal, because we might be ending up storing all the intervals in A and B in the result if there is no intersection at all. So we would need the combined space of A and B. So O of m plus n would be the space complexity as well. So I hope you find this helpful, and if you do, please like, share and subscribe. Keep coding and take care, guys.